Hi, folks. We are going to be talking today about fractions, everyone's favorite. So let's get right into it. So before we even move forward, let's talk about the two parts of the fraction. So we have our fraction bar, right? So and at the top, we're going to have our numerator. So you're going to have our numerator. And on the bottom, we have our denominator. Now, what do these numbers actually represent, right? They have a specific meaning. So I'm going to explain this by drawing a picture for you. So the denominator tells us how many pieces we need to have one whole, right? So let's say you have a chocolate bar, and that chocolate bar has three pieces to it. So the three pieces, in order to have one whole chocolate bar, you need all three pieces of that chocolate bar, right? So if the numerator tells us how many pieces of the whole do we have? So if we need three to make one whole, the numerator tells us we have two of the three. So we do not have a whole. And a fraction is a representation of a number that is not whole. It's not a completed number, right? There's two ways that we show these with decimals and with fractions. So when you see 2/3, it's telling you that in order to have a whole number, you need three out of three pieces filled in. But our numerator tells us we have two, so we only have two out of three pieces filled in. So what we're going to be learning about today is finding the common denominator between two different fractions and what are the equivalent fractions that we're going to get once we find those common denominators. So before I even get into the common denominator, I want to talk about this notion of equivalent fraction, right? So this fraction that I have here is 2/3. So let's say I made the exact same figure, okay? I have the exact same figure here, but I decided, hey, I had another friend come, so I want to break up my chocolate bar even more. I want to break it up in more ways, right? So I'm going to break it up like this. So now I have 6 total pieces of chocolate, right? If I break it up this way, I have 3 total pieces of chocolate. But the value of the whole chocolate is still the same, even though I break it up and it looks different. Even though I break it up into smaller and smaller pieces, once I put all those pieces together, I'm still going to have the same whole, right? And let's say I have the same 2/3 amount of my chocolate bar left. So what I'm going to do, I'm just going to copy the coloring pattern that I have on the previous one. And if we count, right, if we go back to a minute ago, our denominator is how many pieces we need to have the whole, right? So 1, 2, 3, 4, 5, 6. And our numerator tells us how many of the pieces we actually have. 1, 2, 3, 4. So as you can see, the area of the shaded portion is the same, even though we represent it differently. Okay, so that's what we mean when we say equivalent fractions. These are equal. So let me say that again. These are equal. They mean the exact same thing. If I had one candy bar and I broke off two pieces for you, like this, or if I took that same candy bar and I broke it into six and gave you four pieces, you would still have the same amount of chocolate, even though it would look slightly different. Okay? Very, very important concept to understand. If this does not make sense to you, please come into open Zoom. We're going to do some stuff in small group, fold some papers up, and kind of get an idea of what that means with some hands-on learning. But this is a very important concept for you to know. So if we have two different fractions, right? Let's say we have 2/3, 2/3, and 1/4. Okay, so 2/3 here, shade in those two, and I have 1/4 here. Because the denominators are the same, are different, I apologize. Because the denominators are different, it's going to limit what we can do with these fractions. So oftentimes you're going to be asked to change the denominators into something that's equal so that we can compare, right? We can compare the same with the same. So one thing that you're going to do in this case is you have to find out what that common denominator is. Get a denominator that they're both the same, so they both can be, you can add them later. Later you might subtract them. Later you might compare them, as I said earlier. There are multiple ways to find the common denominator and the equivalent fraction between two separate numbers. This is the way that I find to be the easiest. I like to do it mathematically. So I'm going to make a table. I'm going to put 3 and 4, right? Because one denominator is 3, the other is 4. And what I'm going to do is I'm going to write out the factors of each of these numbers. You know, actually might make it a little bit easier. So let's add another column here. And the factors are, so I'm gonna write out, sorry, not the factors, I apologize. I'm gonna write out the multiples, right? So if I do 1 times 3, I get 3. 1 times 4, I get 4. And I'm gonna keep filling out my table until until I find the least common multiple, the smallest number that exists in both of my list here. Okay, so if I'm multiplying by 2, 2 times 3 is 6, 2 times 4 is 8. If I multiply both by 3, 3 times 3 is 9, 3 times 4 is 12. If I multiply them all by 4, 3 times 4 is 12, 4 times 4 is 16. Now if we finish out here, so if I do 5, I'll have 15, and I'll have 20. So now that I have a few multiples here, I'm going to look and see, is there any number that's the same in both lists? And if you're looking carefully, you're going to see that there's a 12 here and there's a 12 here. And there's no other numbers before that are the same. So this is the smallest number, the smallest multiple that 3 and 4 both share. Okay? So again, 12 is the smallest number that 3 and 4 both share. This is like, in my opinion, the hardest part. Once you get here, the rest is really simple. It just takes a little bit of work. So you have to internalize the process, but it's not a difficult process. So now, in order to turn our 3 into a 12, we had to multiply our 3 by 4, right? 3 times 4 gave us 12. So what you're going to do is take this 2 over 3, and you're going to multiply it by 4 over 4, okay? Not just by 4. You want to do 4 over 4, because 4 over 4 is the same thing as 1. So we're changing the way it looks, but we're not changing the value. We're creating an equivalent fraction, okay? So similar to before, we were doing 2 over 3, and I broke up the fraction again, and I got 4 over 6. That's the same thing as 2 over 3 times 2 over 2. So you have to have the same numerator and denominator when you're getting those equivalent fractions. Excuse me. And this is something that many students struggle with, but it's not about difficulty. It's about repetition, and it's about practice. If you don't practice this, you'll never get it. You won't understand it. But if you commit to putting in some time to getting better and practicing this, it will become second nature eventually. So 2 times 4 is 8. 3 times 4 is 12. Okay? So here, let's look at 4. So 4, 8, 12. In order to get to 12, we have to multiply our 4 by 3. So I'm going to take this fraction here, 1/4, and I'm going to multiply it by 3 over 3. And that's going to give me 3 over 12. So my common denominator between 3 and 4 is 12. That's my common denominator. My equivalent fractions, the equivalent fraction for 2/3 is 8/12, and the equivalent fraction for 1/4 is 3/12. Okay, I'm going to give you one more problem to work on your own. And I want you to pause as we go through the steps. Once you are finished, if it's not making sense, please write down some questions that you're having so that we can discuss them in small group. So if I have 1/5 and 3/4, and I want to know what is the common denominator between these two. The first thing I want you to pause, and I want you to try just the first step. What was the first thing I told you to make? If you said make a table, that's correct. So I'm going to put 3 columns here. Okay, 4 and 5. And the reason I put the 4 and the 5 there is because that is the number of my denominators. And then I'm just going to go through and multiply through for each, right? So 1 times 4 is 4, 1 times 5 is 5. 2 times 4 is 8, 2 times 5 is 10. 3 times 4 is 12, 3 times 5 is 15. So I'm going to just do a quick check. I still don't see any numbers that are the same in both of my lists here. Okay, so let's keep going. So if I have 4, 4 times 4 is 16, 4 times 5 is 20. Again, I'm not seeing any similarities yet. Get to 5. 5 times 4 is 20. 5 times 5 is 25. Now, if I look here, I have finally hit my first commonality between the numbers. I have 20 here, and I have 20 here also. So the way I turn this 4 into a 20 is I multiplied by 5. So I'm going to go over to my 3/4, and I'm going to multiply by 5/5. That's going to give me 15/20. And for my 1/5, or I can look at my 5th, to get to 20, I have to multiply 5 by 4. So I'm going to go 1/5, 1/5, and we're going to multiply by 4/4, and have 4/20. So our common denominator is 20. Our equivalent fractions are 1/5 and 4/20, and 3/4 and 15/20. Okay, so this one is a little bit tricky at first, but it really comes down to your effort more than anything else. If you are not going to put in the time to understand this, then you won't, because it's not intuitive. It takes time and takes a little bit of effort to be able to understand this. So I look forward to seeing you during small group today, and I'm hoping that I see a lot of you come into Open Zoom, because I know this is a problem area for a lot of students. It's okay not to know. That's my job, is to teach you. It's not okay to not know and then not reach out to get help. Okay, so again, I look forward to seeing you guys. Good luck.